So far, we talked about linear differential equations and how to model and solve them. Now we're going to talk about a nonlinear differential equations. An example is logistic differential equation. Recall that, well, when we start talking about an exponential growth model, our assumption was that the rate of change of the population with respect to time is proportional to y itself, so k times y. But in reality, when we are dealing with the population, we need to consider that there is a maximum or limitation for the population. In reality, we need to consider a maximum limit for the population. It cannot grow indefinitely. This limit for the maximum of population is called the carrying capacity. So L, or carrying capacity, is equal to the maximum limit of the population. So now that we know this fact, how do we formulate the rate of change of population with respect to time? The formula is dy dt equals to, well, here you have k times y, parentheses 1 minus y divided by L. This is a nonlinear differential equation, and it's called logistic differential equation. So it is non-linear. Question is, how do we solve this differential equation? To solve this differential equation, let us try using separable differential equation method. If we write this as dy divided by y times 1 minus y divided by L, on the right hand side you have k times dt. As you can see, it just wrote this in separable form, so we can take the integral of both sides. The integral of dy times L divided by y times L minus y is equal to the integral of k dt. This becomes, using the partial fractions, it's 1 over y plus 1 over L minus y dy equals to the integral k dt. We have ln of absolute value of y, and here you get minus ln of absolute value of L minus y equals to kt plus a constant of integration. So ln of absolute value of y divided by L minus y is kt plus c sub 1, or y divided by L minus y is e to kt plus minus e to c sub 1. So y divided by L minus y is equal to, let's call it, for example, c e to kt. Now we can isolate y on one side. How do we do that? Multiply both sides by L minus y. So pure algebra, y becomes c to e to the power kt times L minus y e to kt times c. Let me just move this a little bit here. And then if you bring this term that has y in it to the other side, you can factor out y. You get 1 plus c e to kt equals to c e to kt times L. So y is c e to kt times L divided by 1 plus c e to kt. a solution, general solution for logistic differential equation is given for us here.